So last time we were talking about rationalizing the denominator when I only had a single piece in the denominator. Now I want to look at what would happen if I have a binomial down here. Something like the square root of 2 plus the square root of 7. We talked about this at the end of class last time, how we want to create a difference of squares. We want to create something so that these radicals will be able to go away. And if I create the difference of squares, I'm working with what's called conjugates. A plus b and a minus b are called conjugates. And that gives me a squared minus b squared. That's what I want to have. Because if you look at what we had on the quiz, I had multiplication with radicals, but my answer didn't have a radical, because the difference of squares would cancel those out. Now don't worry, we're not going to make these guys cube roots or anything, because that would be just too much for what we're looking at right now. But I want to create a difference of squares, so what would I have to multiply the denominator times to get a difference of squares? How about the square root of 2 minus the square root of 7? Remember, to be conjugates, you've got to have one that's plus and one that's minus. So whatever I multiply in the denominator, I'm going to multiply in the numerator. Do y'all agree?
Yes.
Now, in that denominator, we are creating a difference of squares, right? And what does that become if I look at the difference of squares? It should give me -5, and if you look at the work that we have here, the behind-the-scenes work, this is like your little thought bubble that we've done before. It's the difference of squares, so that's going to give me 2 minus 7, which equals -5, right? So I just do my little thought bubble down here, so I don't have to bring that in do all these little steps in the main part of the problem. Now in the numerator, you see that I'm going to be multiplying here, so that's going to give me 7 square roots of 2 times 7, or minus, excuse me, minus. Did I say times? Oh, must be having one of those days again. Minus 7 square roots of 7 all over -5. Now we can do better than this. We can just go ahead and simplify this. You could multiply this negative, distribute that out in the numerator, or you can just go ahead and separate this and say that we have negative 7/5 times the square root of 2, and then -7 over -5 is a positive 7/5 times the square root of 7. Okay, so you multiplied in the denominator to create a difference of squares because I didn't have a single term. The stuff that we saw from Friday, we had to kind of complete and make things perfect squares, perfect cubes, or whatever it was that we're dealing with. Here, I've got to make this. I have to make this a difference of squares, so I multiply times the conjugate. Okay. Let's do another one so you can see what's going on here. If I have 12 over the square root of 5 minus 1. You may think back to the stuff we did before and say, if I just multiply times the square root of 5, then I'm going to be okay. If I multiply times the square root of 5, so if I just do this, what's the square root of 5 times the square root of 5? It's just going to give you 5, right? Because it would be the square root of 25, which is 5. But then you have to multiply it times the 1. So although it would get rid of this radical, it gives you another radical, so it doesn't really help you, right? But if I do times square root of 5 plus 1, then what am I creating in that denominator? I've got conjugates, And the product of those will be the difference of squares. And so as I saw in the previous example, I'm going to have the first guy squared minus the square of the second guy. So what's the square root of 5 squared? 5 minus 1 squared, of course, is just 1. Don't you dare tell me 2. So 5 minus 1 is 4. Do you all agree? So what do I have in my numerator? 12 square roots of 5 plus 12, and this is all over 4. Now, can that guy be simplified?
Yes.
How? That's going to give me 3 square roots of 5 plus 3. What do you think?
So, Mr. Craig, is it kind of like distribution a little bit?
I distributed here in the numerator,
Okay.
and down here I'm using the special product from 0308 that gives me the difference of squares.
Right, okay.
And so when I do that, these squares are going to cancel. I get a nice integer value, and then I reduce what I can up here. Remember, when you're doing division, you've got this fraction right here, 12 square roots of 5 over 4, but you also have this guy, 12 over 4, because 4 is the denominator for both of those guys in this expression.
Why would the square root of 5, whatever times itself, be 5? Wouldn't it be?
That would be the square root of 25, right? But then the square root of 25 again is just 5. As we saw before, it's as though the square and the square root cancel each other out.
Okay, okay.
All right, let's try a super duper fun one. If I have 3 square roots of 2 plus 5 square roots of 3 all over 7 square roots of 2 minus 3 square roots of 3. This does look like a lot. I'll agree with you there. But if we go through this piece by piece, it will not be that bad. It's just like the other problems. We have square roots in the denominator. How many terms do I have in the denominator?
2.
When I have 2 terms, I'm going to multiply times its conjugate. That means the result will be the what? Difference of squares. And when I have the difference of squares, I'm not going to have those square roots left anymore, right? So, what is the conjugate that I'm multiplying times? 7 square roots of 2 plus 3 square roots of 3. Now do that in the numerator as well. Do you all agree? Now, what we need to see here is that my denominator will give me the difference of squares. My numerator is a little bit more complicated, and I need to remember to do what up there? I'm going to have to FOIL that because I have a binomial times a binomial. So let's multiply that out and see what we get. When you multiply the first terms, what do we have? 21 square roots of 4. Remember, you have to multiply those radicands together. On the outside, what do you have? Multiply these guys. What do we have?
9 square roots of 6.
We have 9 square roots of 6. Multiply the inside terms. What do we have?
35 and 6.
Well, 35 square roots of 6. And when I multiply the last terms, what do I have?
15 square roots of 9.
Is that right? And then in my denominator, what do I have?
49 times 2 plus 9 times 3.
Well, it's going to start off as the difference of squares. I'm going to show this step here for right now. This does give me the difference of squares. So piece by piece, let's finish working this out. If you look in this numerator, we do have some things that we can simplify because I have this square root of 4. What does this guy give me? And then I also have this square root of 9, which is going to give me 3. So off to the side, I'm thinking about these numbers. What's the 21 times 2? It's going to give you 42, right? And what about this other guy? What does he give you? He gives you 45, so all together I'm going to have 87. Do you all agree? Isn't 42 plus 45 87? Right. So in my numerator, we have what? We have 87, that's the integer part. What about the radical part? I've got 9 and 35, they're both square roots of 6. How much is that? Seriously, what's 9 plus 35?
44.
It's 44 square roots of 6 over. Now let's look what we have in the denominator. This guy is 49 times 2. When you square, remember what we did here before? You square the 7 to get 49. When you square that factor of 2, you get 2. Over here, when I square the 3, I get 9. When I square the square root, what do I get? I get 3. So make sure that you're paying attention to what you're squaring and when. So what is this stuff down here? Excuse me?
98 plus 27.
Nope. 98 minus 27 is the difference of squares. So what's 98 minus 27? Right, so this is my little thought bubble for what this denominator becomes. So my whole denominator is 71, right? Now what I'm going to do is I'm going to separate these guys just like I've been doing, because when we get to the very end of this chapter, we have to separate when we do division. So this is going to give me 87 over what? What was my denominator?
71.
71. Plus I've got 44 over 71 square roots of 6. Because think about this. This is what we have right here, right? Isn't that still 87 plus 44 square roots of 6? But it was all over 71. So each of these guys is over 71.